We're going to start off in this chapter dealing with the hypothesis test. And so this video, for the most part, is just to give you an introduction to what it is and help you understand the basics of it. So, extrasensory perception. Is there such a thing? So here's some data. Take some time to look at it. Now, we want to see if there is such a thing. And so one way to actually test it is with these cards. Basically, we have 5 cards. Someone draws one at random and then supposedly tries to telepathically communicate it to somebody else so that they can pick up the same card. Well, with 5 cards, you would expect that 1 out of 5 times, or a probability of 1/5, somebody would actually guess correctly. Just random. If somebody picks a card and the other person just randomly chooses one of the 5 cards, they get it right 1 out of 5 times. So that's our basic probability that we want to be comparing it to. But we know that when we do a sample, that it's not necessarily always going to be 1/5. Might be a little bit more, might be a little bit less. It's going to vary from sample to sample. So how do we determine if the sample that we get is really far enough away from 1/5, meaning far enough above it, to show that there actually is evidence for ESP? So to do that, we want to do a statistical test. And that's our hypothesis test that we're going to be talking about. And we do that to be able to determine about the claim that we have about our population. In this case, if yes, there is ESP, or no, there is not. So for this experiment, we want to see if our proportion is really a fair amount higher than 1/5. So when you're doing your testing, we really have 2 things that we're going to look at, 2 hypotheses. We have our null hypothesis, which is kind of our initial claim, and it's always going to be that there is no difference. So your null hypothesis is always an equal to. Your alternative hypothesis is that which you're kind of seeking claim for. And that's either going to be a greater than, or a less than, or a not equal to. Now, your hypotheses are always referring to your population parameter. So if you're dealing with average, that is your mu, because that's dealing with your population. Or if it's a proportion, that's going to be your p with nothing above it. So we have our initial hypothesis, our null hypothesis, and that's H with a little subscript of O after it. And then we have our alternative hypothesis, which is H with a subscript of A. These are the 2 hypotheses that we're going to try to be working with and trying to find evidence for one or against one. So hopefully we're going to be finding evidence for our alternative hypothesis, which will essentially say our null hypothesis is not true. And we'd already mentioned that your null hypotheses and your alternative hypotheses are always dealing with your population. So we have all possibilities. From that small part, we have our null hypothesis. And we're trying to find evidence against our null hypothesis so that we can reject our null hypothesis. You might think if we find evidence against our null hypothesis, that means we have our alternative hypothesis would be true. Well, no. All we can do is say that we failed to find evidence um, against our null hypothesis, or we found strong evidence against our null hypothesis. We really only make claims about or conclusions about our null hypothesis, whether to reject our null hypothesis or fail to reject it. Now, if we reject our null hypothesis, it gives us some evidence for our alternative. However, there's more than just one alternative hypothesis, and so we can't necessarily say that, yes, we proved it. All we did was basically say that we rejected our initial null hypothesis. So let's talk about our hypotheses here for our ESP experiment. So we have our null hypothesis. It's P, because we're dealing with the proportion, and it's equal to 1/5. It's always your population parameter, either P or mu, and it's always an equal to. And it's always going to be equal to your initial conclusion or initial guess. Then we have your alternative hypothesis, and that's either going to be, it's going to be the exact same as what we have up here, but you're going to replace your equal to either with a greater than, or a less than, or a not equal to. Which one it is all based in the context of the question that's being asked. For this one here, to show that we have evidence for ESP, we need our proportion or our probability to be greater than 1/5. So your null hypothesis always has an equal to. Your alternative either has a greater than, a less than, or not equal to. So consider sleep versus caffeine. So we give students words to memorize, and then either assign them to take a 90-minute nap or a caffeine pill. And then 2.5 hours later, we test their recall. And we want to know, is there a difference between the recall between sleep and caffeine? We have our explanatory variable being sleep or caffeine, and our response variable being the number of words that they recalled. So if we're looking here, we're looking at the average or the mean, so we're dealing with mu. We have our mu for our null hypothesis of the sleep, because that's what the S stands for, and C stands for the caffeine. Always going to be an equal to here for comparing our two means, because there is no difference. And in this case, we were just wondering if there was going to be a difference, so that's a not equal to. If it was implying that we thought one was greater than, we'd have a greater than sign here. If we thought one would be less, we'd have a less than sign here. Now, instead of writing your hypotheses up here, we could write them down here, and it would really mean the same thing. If you subtracted the mu of your caffeine from both sides, you get this statement here. And the same idea down here. If you subtract the mu of your caffeine from both sides, we would get this. Be familiar with both ways to write your null hypothesis for the difference in two means or the difference in two proportions. Whether you write it this way or write it this way doesn't make a difference. You're going to be seeing both in your problems for this class. So write down what you think your null hypotheses would be for this situation. So pause the video and go ahead and do that for each one of these. So for this one here, we're going to have an equal to. We're going to assume that P, or that they're equal, and P sub F is the female proportion, P sub M is the male proportion. Always going to be an equal to. It is possible you could have your null hypothesis being P sub F minus P sub M equals 0. That's perfectly fine. We're just trying to see if they're different. So that's the not equal to. And then once again, you could say P sub F minus P sub M not equal to 0. So down below here, once again, we're dealing with averages, so we're not going to be using P's for proportions. We're going to say that it's equal to 7, mu is equal to 7, and we're thinking it's less than, so that's why we have a less than sign down below. Now, statistically significant, that's really what we're kind of hoping for, because that gives us evidence against our null hypothesis. Basically, if we find out that the likelihood or probability that getting this sample results that we did was so small, it's unlikely to occur. So if our probability, which we'll be getting to saying is our p-value, if the probability of getting our results we did, assuming the null hypothesis is true, we get a small p-value, a small probability, then we say it's statistically significant. It's likely that our null hypothesis is false. So if we come across a situation that is statistically significant, we say we have convincing evidence against the null hypothesis, which really gives us evidence in favor of our alternative. If our sample is not statistically significant, our results are inconclusive, and we say we fail to reject the null hypothesis. If it is statistically significant, we reject the null hypothesis. So going back to our ESP one, if the results are statistically significant, then we would reject your null hypothesis. We would say it's likely that the probability is not 1/5, because that's what it would be for just guessing, and we would find evidence to support ESP. We can't prove it, but we can find evidence to support it. So let's go ahead and say it's not statistically significant. Well, in that situation, we would say that we would have something that's not necessarily real far from 1/5, and we would have no evidence to conclude that there is USP. So we would fail to reject that there would be ESP. So we look at our data, we do a sample, and we want to assess our sample results compared to the population. We then go ahead and make our hypotheses. We have our null hypothesis, which is always an equal to, meaning there is no effect or no difference. And then we have our alternative. And it's going to be the same setup, but either with a greater than, a less than, or not equal to compared to your null hypothesis. Then we do our test, and then we go ahead and decide if it's statistically significant or not.